Good afternoon, class. Today we'll be discussing with you manufacturing operations information systems, which are a set of applications that create value by supporting the planning, controlling, and success of a firm's manufacturing processes. These systems can help management cut costs, increase production, or bolster quality of their products. Different companies include different branches within their manufacturing information system. Typically, inventory control is often considered a function of the manufacturing information system because it deals directly with production, which is what makes up the inventory. Some businesses also include purchasing in these systems to optimize efficiency by allowing the system to determine when to purchase certain items as to not disrupt production. However, a manufacturing operations information system is not a standalone infrastructure. It is facilitated by people and other systems and comes as a requirement from the production process in use by the company. These systems are most helpful in large-scale production processes because it allows for consistency in output. The drawbacks of it are it is very expensive to implement, and in training employees and educating them about its use can be time-consuming and very costly. These information systems have a huge impact on all other operations that a firm is involved in because problems, delays, or complications means that the firm does not have a product to sell, and this can halt operations entirely. Accounting and finance operations are affected because this system must enable them to determine a cost structure and fund allocation for a project or a group of products. Marketing is affected initially because it must be able to sell the product being produced, and efficiencies can help determine sales promotions as well as distribution routes. Even human resource planning and management are highly effective because an efficient system can be the difference between hiring 10 employees or hiring 100 employees. We will now talk about some common manufacturing information systems. Computer Integrated Manufacturing, or CIM for short, is a system that automates the production process and integrates the different layers of the production process into a coherent production design. Its goal is to create a flexible and responsive manufacturing process by integrating all the components and creating one big picture by which we can produce products. Another common manufacturing information system is computer-aided manufacturing, which involves integrating machines into production process to benefit from their automation and accuracy in the production process. One widespread manufacturing information system is computer-aided design, or CAD for short. It involves using computers that aid in the design of potential products. CAD is very important when developing products because it gives managers the opportunity to see almost exactly how the product will be designed and function. One very common use of it is AutoCAD in engineering firms. They use it to simulate 3D designs for construction. Just-in-time inventory management is a computer inventory management system that orders required parts and materials right before they are going to be used to manufacture the final product. Production scheduling is a system that schedules the use of facilities to allow for the most efficient production process. Material Requirements Planning, or MRP, is a system that determines which parts will be needed at certain times in the production process. It is like a full list of material resources required to produce a final product. Material Resource Planning, as opposed to Material Requirements Planning, is known as MRP2. It's a more advanced version of Material Requirements Planning. It combines the information provided by MRP and combines it with production scheduling and even labor management information systems to give the firm an even more comprehensive list of inputs needed in the manufacturing process. Supply chain management is a type of information system that manages the movement of materials from suppliers through production and down distribution routes. Although it sounds out of the scope of manufacturing information systems, it is heavily involved because the manufacturing process benefits greatly from being able to control the influx of materials as well as the outflow of the product being produced. It can help management become more efficient by working with reliable suppliers and allocating production to areas with higher demand.
Now, we have chosen the various stages in the cotton manufacturing to be the contents of our business process that best supports our operations manufacturing activity. The first stage of our process is the picking and harvesting, where this used to be done manually, or was considered to be a very inefficient and tiresome job. However, now machines have the ability to harvest cotton much more efficiently, where 5 minutes of machine time are equivalent to what a cotton picker can manage in a whole day. It works by using lifters to locate the cotton plants between rotating drums. These are covered in spindles which would cut the cotton off the stem, making the process much more efficient and simple. Our next process is the drying and cleaning of our cotton, where farmers gather all the cotton that they harvested to pour into this cotton king machine, where it functions by driving the cotton through a fine mesh that would separate all the unwanted seeds and leaves from our cotton product, that could now be ready to be shipped to a blending manufacturer. The blending manufacturer would then refine the cotton through 3 more processes called the blow room, carding, and finally spinning. Once in the blow room, a machine uses mechanical arms to pick the fibers from the top of the bales. Once those fibers are picked, they are then blown through air ducts into special mixers before they're cleaned by the process of blowing, allowing the trash to fall out at the bottom. Our cotton then moves through a carding process, which is a process of untangling the fibers by combining and pulling the cotton into a type of web. Then they're stretched together to make a 6th strand of what is called a slither. Then our cotton goes through its final process of spinning, where cotton slithers are pulled and twisted at a rate of 120,000 revolutions per minute, allowing for our finished cotton thread. Now we would like to leave you with what we think of a business as-is modeling taken to a different level. Hope you enjoy our short video.
The Da Vinci surgical system is the most advanced platform for minimally invasive surgery available in the world today. The integration of high-resolution 3D vision, wristed instruments, and intuitive motion control enable the Da Vinci surgeon to transcend the limitations of conventional surgical technologies. 3 network components comprise the Da Vinci surgical system: an ergonomic surgeon's console, a patient-side cart with 4 interactive robotic arms, and a high-definition 3D vision system. Seated at the console, the Da Vinci surgeon views a remarkably clear 3D image of the surgical field. The system scales, filters, and translates the movements of the surgeon's hands on the master controllers to 4 interactive robotic arms on the patient cart. The precisely controlled micro-movements of the Da Vinci instruments are enabled by the computer processors of the system. These dedicated processors perform millions of safety checks over the course of a procedure for enhanced surgical precision and control. Da Vinci EndoWrist instruments are designed with a unique wristed architecture that provides 7 degrees of freedom for a range of motion greater than even the human wrist. This proprietary design enables surgical maneuvers impossible with conventional laparoscopic tools. The system requires that every surgical maneuver is under the direct control of the surgeon. Redundant safety checks prevent autonomous movement of the instruments or the robotic arms. The Da Vinci S surgical system moves surgery forward with a new level of technical capability that enables minimally invasive surgery in complex procedures as never before. Da Vinci provides a streamlined surgical experience that benefits the hospital, the surgeon, the OR team, and, most importantly, the patient.